Okay, here we have this double integral right here, and as always, please pause the video and try this first. Okay, how did you guys do this? Well, in fact, I will show you guys 3 ways to do it. The first way is just that we can integrate this as how it is. Because remember, a double integral is just an integral inside of another integral, right? So we can just integrate this guy in the y world and then plug in this and then subtract, and we'll finish this in the x world. And let's see if this is going to work out or not. So first of all, we will just have the integral from 0 to 3, and these are the x values, okay? Keep that in mind. And then we are going to integrate this in the y world. So that means x plus third power, it's like a constant. When you integrate that, this is actually really easy because you just get x plus third power times y. You put a y next to it, that's all. And then to integrate this guy, just pay attention to y squared. You add 1 to the power, which is 3, and you divide by 3, which you have 1/3. So that's plus, and the x is, just a constant, so you maintain that, 1/3 x, and then y, and then to the third power. This is pretty much it. And we have to just plug in, right? So remember, these right here are in terms of y. So we are saying that y is equal to negative square root of 9 minus x squared up to y is equal to positive square root of 9 minus x squared. And then in the end, we still have the dx, of course. And you will see that this is equal to the integral from 0 to 3. We just have to plug in this into all the y's. And you will see something is really bizarre, because when you plug in this right here, we will first have x to the third power times the square root of 9 minus x squared, and then plug in this right here, we have plus 1/3 x, and then we have parentheses square root of 9 minus x to the second power and then to the third power, and then we have to minus. I know you can do the, just ignore the second part and multiply by 2, but let me just show you. Minus, plugging this into y, we have x to the third power times negative square root of 9 minus x squared, put parentheses maybe, and then plugging this into here, we have plus 1/3 x times negative square root of 9 minus x squared, and then to the third power. Yeah, like that. And then in the end, you still have that dx, okay? But do you think we should continue? I don't think so. Because, for example, this right here, okay, we have to integrate x to the third power square root of 9 minus x squared in the x world. Fine, if you know your Cal 2, go ahead. Watch my video for that, right? You can do trig sub or whatever substitution that you want. But how would you integrate this guy, right? You can still do it, but seriously, oh my god, this is just a lot of integration work you have to use. You have to do a lot of integrals. So I'm actually going to call this a sad face, because it will be a lot of work from this point on. So I will just leave that to you guys, okay? Here's a better way, slightly better way. I'm not saying it's the best way, but perhaps this is easier. The idea is that sometimes when you have a double integral, this is given in terms of dy dx. If you change the order of integration, this right here, instead of dy dx, you have dx dy. Sometimes good things might happen. And let me show you how to do that. To do so, we have to first get the region that we are talking about first, right here. So by looking at these equations, you know that this is y equal to negative square root of 9 minus x squared. And hopefully by now, you know that y is equal to negative square root of 9 minus x squared represents the bottom part of the circle with radius 3, right? So this right here, the graph is just the bottom part of the circle like this. And the radius is 3, so this is negative 3, this is positive 3. So this is the starting y equation, and then up to this, that's just the top part. So we have pretty much the whole circle like this, okay? Well, this is just the y, and now let's look at the x. X goes from 0 to 3, so that means we just care about from here, which is 0, right? This is x equal to 0, up to positive 3. So we just care about this portion of the circle, like the right half circle here. Okay, now, in order for us to change this into dx dy, you have to actually just make this work first. And I will put down the blue integral outside for the dy, okay, and then integral in black is the dx. And then the integral stays the same, of course, x to the third power plus x y squared. And then we have to do it with respect to x first, and then y, right? So we have the dy right here. Let's look at the x. For the x, starting x value is, of course, 0. So this is still good. This is still 0. Now, from here to here, and we are talking about this equation now. And once again, the equation of the circle, as we know, this is x squared plus y squared equals to 3 squared, which is 9. And earlier, if we isolate the y, we get this and that. This time, we want to isolate the x. So let's move the y squared to the other side. We get x squared equal to 9 minus y squared. And let's take the positive version of the square root only, because we have positive x values right here. So we have x equal to positive square root of 9 minus y squared. So we go from 0 to positive square root of 9 minus y squared. Okay? So that's pretty much it for the x. And now let's look at y. Well, for y, this time the bottom number right here is -3. That's the starting value for y. And why -3? Because the radius of the circle is 3, right? So you have the bottom, so that's why it's -3. Up to here now, which is +3. So this is pretty much it. This is how you change this integral into this right here with respect to x first and then y. Okay, now let's see how we can integrate this guy. Let's just go ahead and put down the integral from -3 to 3 because that's for the y. And then we are going to integrate this guy in the x world first. X to the third power will give us x to the fourth power over 4. So let me put this down as 1 over 4 x to the fourth power. And then we will integrate this guy in the x world. Y squared is like a constant, so we just have to integrate x, right? We get x squared over 2. So I'll put this down as plus 1/2 x squared, and we maintain the y squared like this. And this time, we are going to pay attention to the x, okay? Because now we have to plug in x is equal to 0, and then x is equal to that, which is the square root of 9 minus y squared. And then in the end, of course, we still have to have the dy. This is actually much better. Okay, so for the dy, we still have the blue integral. So let's put this down, -3 to 3. Now, when I'm plugging this into x to the fourth power, square root and then fourth power becomes just the second power, right? So we have 1 over 4, and then we will have parentheses, and just the inside now, that's 9, I will put this down in red, why not? 9 minus y squared, and then to the second power only, okay? Square root and then fourth power cancel each other out, and we end up with just the second power, right? Cancel out, things like that. Anyway, plugging this right here, square and square root cancel each other out completely. So we have plus 1/2, and just the parentheses now, 9 minus y squared, and then we still have this y squared, and that's pretty much it, right? Because I should plug in 0 into here and here, but the best part is you minus 0 and then plus 0 like this. So which is doesn't really matter. You can just erase that. You know, it's calculus 3 now, so yeah. So just be sure that you have this habit. Just be sure you also plug in the lower bound and then be sure. Anyway, so we are done with this, so we can close that, and then we still have the dy, of course. This right here, it's easier to integrate because it's just a polynomial. So you can just actually multiply this out, distribute this, and then collect like terms maybe, and then just do the reverse power rule to integrate. And plug in numbers, maybe you can say this is even function. So you can just actually go from 0 to 3 and multiply that result by 2. And you do whatever that you need to do, okay? And you do all the work. On the test, do not just put on dot, 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 and you actually have to show your work. But let me just tell you, if you work that out, you get 486 over 5. And of course, if you work this out earlier, you get the same answer, but the integration steps right here, they are not that pleasant, unlike this right here. So I'll leave that to you. Okay, so these are the two usual ways if you don't want to deal with something too high-tech. But sometimes when you are dealing with something that's more high-tech, it's actually much easier. So I'll show you guys that as well. The third way is that, okay, here we pretty much have a circle. Look at the integrand. We have x to a third power plus xy squared. If we factor out the x, we will end up with x times x squared plus y squared, right? So let's do that right here. Let me show you. Factoring out the x, we get x squared plus y squared. Hey, look at x squared plus y squared. This suggests us to use polar coordinate because this right here is just r squared. And also, the region is pretty much like a circle, so it's totally doable and nice and easy. So the third way is we'll be using polar coordinate. So let me just put this down by polar coordinate, okay? And here are the ingredients that we need. So let me write this down for you guys. Keep in mind that x in the polar world is equal to r times cosine theta, and y is equal to r times sine theta. And the beauty is that x squared plus y squared gives you r squared. And when you are talking about the integral situations, you also have to remember dx dy. Okay, I put on dx dy, but it's okay to say dy dx. Okay, doesn't really matter for the differential part. dy dx, dx dy, once you change that to the polar coordinate, you get r times dr d theta. Always remember this little r right here. And if you want to know why, this right here is a Jacobian. Okay, you can use the Jacobian matrix to figure this out. But if you just are doing this in a hurry, just use this substitution. That would be nice. Okay, now let's see. We will take the original double integral and change that into the polar world. Okay, let's see how we are going to do that. Well, I am going to do this with respect to r first and then theta, just like this, okay? And I will have to look at the picture again. I will show you. So let me just draw the picture again. The region is pretty much just the right part of the semicircle, so I'll just put this down, okay? And I will just tell you guys the following. I will put down the integral in black first, I guess. And then this right here, I will just, as I said, I will put a theta on the outside, so put on theta. I will figure that out, don't worry. And then this right here, it will be the r, okay? And let's figure out the function part. This is not bad. First, we have the x. X, as I said, is r times cosine theta. So that's just r times cosine theta. X squared plus y squared, that's nicely equal to r squared. So we multiply by r squared. dy dx, it's that. Once again, the order of this doesn't really matter. So I will just put this down. I will put down multiply by, I'll just put on another r like this. And then I want to do dr. And then d theta. Okay, so hopefully this is clear. Now figure this out. Okay, perhaps we can figure out r first. Well, r is the radius, right? And you want to go from the origin, and then you want to hit the circle right here. And the radius of this circle is 3. So you know it's pretty much you go from 0 and to 3 like this, right? So from 0 and then you go up to 3. So r goes from 0 to 3 like this. And theta, it's the angle, right? And you see, you technically have to draw the picture from here and then to here, right? Because you have to rotate like that. So the theta here is negative pi over 2. And then this right here is positive pi over 2. Right? This is negative pi over 2 up to pi over 2. So theta is negative pi over 2 up to pi over 2. So this right here, it's pretty much it, how you change the original double integral by using polar coordinates. So yeah, so pay attention to the radius of the circle and also the angle. And now, of course, we have to finish this, right? So we will let's see. The integral on the outside is in terms of theta from negative pi over 2 to pi over 2. And I know this is an even function, but just let me do it like this way. Anyway, here we have r times r squared times r. We get r to the 4th power. And let me just write this down again from 0 to 3 for the r. And we have r to the 4th power cosine theta dr and then d theta, right? Okay, let's integrate this guy in the r world. Cosine theta will be the constant, so it stays. And you integrate this guy, you get 1 over 5 r to the 5th power. You add 1 to the power, so just like that. And then, of course, you pay attention to what r is, right? And of course, you also write down the cosine theta. And these values are in terms of the r. So you have to go from r equal to 0 up to r is equal to 5. And then in the end, you do the integral in the theta world, which is negative pi over 2 to pi over 2. And then you have the d theta on the outside. Okay, let's see, what do we have? We still have this and that. So the integral negative pi over 2. I know we can do the even and odd situation, the even integral, whatever, but yeah, I will just do it this way. Anyway, r is equal to 3, sorry. R is equal to 3, the power is equal to 5. Alright, so plugging 3 into this r, 3 to the 5th power, just work that out, you get 243, okay? This is 3 to the 5th power. And then you still have the over 5, so we have 243 over 5. So that's pretty much it. And of course, you maintain the cosine theta. And then when you plug in 0 into this r, you just get 0. So minus 0, which doesn't matter. And then you still have to finish this in the theta world. Seriously, I will just do it like this. Okay, so don't worry about even honest. Up to you, seriously. Let me maintain this. This is 243 over 5. Integrate cosine theta in the theta world. We get positive sign. So we have positive sine theta. And this theta value goes from negative pi over 2 to pi over 2. So you just plug in this right here real quick. I know the answer is 2 already, but 2 times that, but let me just show you guys all the work. 243 over 5 times sine of pi over 2 minus sine of negative pi over 2. Okay, as you guys can see, this right here is 1 minus negative 1, which is 2 times that. All in all, you get 486 over 5, which is really, really nice. Okay, that's the best answer that we will have for this situation. Anyway, hopefully you guys like this video, and let me know which method that you guys like the most. And if any of you guys try to do this all the way, let me know that as well. But as always, if you guys are new to my channel, please subscribe. I appreciate that so much. And that's it.